All right there, folks, on the electronics boards. I posed a question regarding interrupts and using an Arduino, and my results were rather disappointing. While my approach worked, I was having some inconsistent results. Anyway, my question was, how do I fix this? And thanks to some constructive feedback, I was reminded that, hey, switches bounce. So I need to filter that out and account for it. There's different approaches. There's hardware and software. One of the optimal approaches is to use Schmidt triggers. I will do that in the future. I didn't have any handy. I'm thinking about maybe using just a 4011 CMOS logic gate, a pair of those to help me, or maybe just a hex inverter. But for now, I took an RC approach with a diode. The simple approach I took, I added diode D1, which is a silicon diode, 1N4004. I added R2, just a 470 ohm, in parallel with the diode that jumps across and allows back EMF to drain a 1 microfarad capacitor C1 tied to ground. And that's all tied into pin 2, which then pushes in, hopefully, filtered voltage on pin 2 so my interrupt works consistently. Like I said, just a simple addition of a resistor, a 1 microfarad cap, and that diode. I don't think you necessarily need the diode. I put it in there because, hey, why not? A lot of the better circuit design approaches used it, so I followed their lead. And right now I have 0 volts on pin 2, and the Arduino is cycling through its main routine. The interrupt has not been triggered. And I have my Rigel set up over here. Nothing's on there. I have it set up for 1 shot. And what I'm going to do is kick off the switch and see if I get a triggering event. Hit the switch. Interrupt is triggered. We go to 5 volts on the rail. We come back over here and I show you look at this beautiful reference. We go from 0 VDC rail. On pin 2, it climbs nicely. I'll even change the time scale a bit. Right now we're at 5 milliseconds. If I punch this out a little bit, 2 milliseconds, you can see we have a nice curve, voltage curve. I did post pics earlier where I was showing some chatter on the pin, and that chatter was giving me inconsistent results. I'm going to go ahead and clear this out and check this out. Interrupt is triggered. We're on 5 volts on the rail. I'm going to go ahead and hit the bang switch. Boom. We have a drop of 5 volts down to 0. Nice and clean. The loop is, the trigger's been released. And we're at 0 volts on the rail. Consistent as all get out. I'm very pleased with the results. I really appreciate the positive feedback. I'm going to go ahead and change the domain a little bit. Go from 10 milliseconds to 5, from 5 to 2, and down to 1 milliseconds. Check out this thing. A little bit of weeble wobble right there, but not enough to affect the outcome. But look at that. We have a nice fall. Looks like it's calculating at 1.200 milliseconds. No chatter on this thing. So it's sending a clean voltage pulse into pin 2, our interrupt 0 pin. And this thing works like a champ now. Look at this, 0 volts on the rail. We have our switch. I'm going to go ahead and take the liberty of resetting this. Going to go ahead and show you. Bang, look at this. And then we can tighten it up from 1 millisecond to 2 milliseconds to 5. Look how nice and clean this is. And if I pull it up to 10 milliseconds resolution, it's not quite a straight square wave, but it's good enough to properly trigger the interrupt. Oh, such a beautiful sight to see. Oh my goodness, no chatter. I would say this switch here is effectively debounced. I'm thrilled. This thing works consistently. Boom, trigger released, 0 volts on pin 2. Boom, 5 volts on the rail. We should get an interrupt triggered. Boom, reset it down to 0, released. Boom, interrupt triggered. Boom. 0 volts on pin 2, released, boom. Interrupt triggered, 5 volts on the rail, and the proof is in the pudding. When you come back over here, the scope tells you it's the tail of the tape. Bam, beautiful, love it. Thank you guys for the input and the constructive approach. Now my interrupt works flawlessly every single time. Taking this simple approach, I will use Schmidt triggers, or I'll try a buffer approach to get it even tighter. Obviously, this is just a human interface. I think in the future, like I said, once I get the Schmidt triggers in there or whatever, especially if I'm driving it with like a 555 or some other kind of square wave source, or maybe like a rotary encoder or something of that nature, I will punch it through digital filtering to make sure I get 100% consistency, because even with this sub 2 millisecond decay, and I could probably fine tune that RC circuit, this was just plug and chug, I can get consistent results. This is a known thing. I wish I would have just did some more research on this ahead of time, and I took the path of least resistance, no pun intended. But again, thank you guys for the positive feedback. I really appreciate it. Yeah, terrific. Great resource. Thanks for pointing me in the right direction, folks. Appreciate it.